Hello friends, I am Dr. Niyaz Ahmad and you are watching Gen Next Edu Learners. So let's begin with a new topic. So today, before starting the topic, just we are going to see an example here. So you can see in this picture what the person is doing. Okay, so the person is pouring water in the glass. So when pouring a glass of water, what generally we think? We usually think only in terms of churning on the faucet until the glass is full and then turning it off. This only things we are thinking when we are just pouring the water into the glass. But if you see here the thinking process, so here basically the thinking process actually happens. What generally we want, that there should be a desirable level of water should be there in the glass. So when we are just filling the glass, so we are just keeping an eye on the perceived gap. Okay, so we are just measuring the current level of water. Accordingly, we just fix the position of the faucet. Then there will be a flow of the water in that. Again, we see the current water level, and then we see the perceived gap, and we also just keep in mind the desired water level, and accordingly we again just fix the faucet position. And when the glass is full, what generally we do, we just change the position of the faucet and we just close that faucet. Okay, so this is the way of thinking generally happens when we pour the water in the glass. Okay, so this is called that we are thinking towards a whole system perspective. So, okay, so we are thinking towards the whole system perspective. So our topic for today is system thinking. We have already seen systems approach. So if you have not watched that video, go to my YouTube channel and watch that video, systems approach, because that topic will help you to understand this topic. So system thinking we are going to see today in detail. I am Dr. Niyaz Ahmad and let's begin with the topic. So system thinking. So what Einstein said about the thinking here. So Albert Einstein once said, without changing our pattern of thought, we will not be able to solve the problems we created with our own pattern of thoughts. So if you are having any problem, means that problem is not resolved. So we cannot resolve that problem by the same level of thinking. What we have to do, we have to change the pattern of thinking only. Then only we will be able to solve the problem. So this is said by Einstein. Then Laszlo in 1997, he also said about this thinking that to live in the third millennium, we shall need new thinking joined with the new ways of perceiving and visioning ourselves, others, nature, and the world around us. So we have to change our thinking. So system thinking we are going to just see in detail. So this concept of system thinking is founded in 1956 by MIT professor J. Forrester. So J. Forrester has first coined this term, that is system thinking, in 1956. So in thinking, we are focusing on how the things interact with each other, constituent of the system. So here we are taking into consideration the interaction of the parts of the system or the constituent of the system. Okay. So here we try to see the learning, or we try to learn to see the world systematically. So here we are learning to see the world systematically, and the system thinking encourages us to see the whole as well as the part. Okay, so we see the whole as well as the part to understand the system. So this is called holistic thinking. Okay, so here the system thinking is also called holistic thinking. So system thinking is nothing but it is taking many interactions into account. So system thinking is taking many interactions in the account, and these interactions happens between the parts, among the parts. So system thinking explore the properties which exist once the parts have been combined into a whole. Okay, so here all the interactions we take into consideration, because those interactions are combined together to form a unified whole. So let's see the example here of the system thinking, how we can take into consideration the whole while the parts of the system generally interact with each other. Suppose in any organization, this number of initiative taken by the organization is normally improve the productivity. Okay, and this productivity leads to customer satisfaction. This customer satisfaction, the customers are satisfied, they will give a sponsorship to the organization. And if this institution or the organization gets a sponsorship, the number of initiative will also, now they will increase the number of initiative again. So if the number of initiative increase, so there will be improvement in the results, and this will also lead customer satisfaction. And if the customer are satisfied again, then institution will be encouraged to take increase the number of initiatives. Okay, so you can see here there is an interaction between the parts. So you can see here in some components or some aspects of the organization there are more than one interaction. Okay, so you can see here this customer satisfaction have number of interaction. It interacts with the sponsorship, it interacts with the productivity, it's also have an influence on the number of initiatives. So here you can find out a number of interactions in the system. Okay, so this is an example of system thinking. So let's go into detail of this system thinking and its components. So let's see the characteristics of system thinking. So the system thinking emphasizes whole rather than its parts. So here we are just focusing on the whole rather than its parts. Here it stresses the role of interconnection. In system thinking we are just emphasizing on the role of interconnection between the parts. So rather than concentrating on the parts, we are giving more importance to the interaction which is happening between the parts. In system approach we are not taken into consideration these interactions, but we have taken into consideration the parts. Okay, but here we are more focusing on the role of interconnections. So it emphasizes circular feedback. Basically you can see here in this diagram also there will be is a circular feedback is there. So for example, A leads to B, B leads to C, and again this C leads to A. So this is a circular feedback. So in system thinking we are focusing on circular feedback rather than linear cause and effect relationship. So we are not concerned about the linear cause and effect relationship. In that generally A leads to B, which leads to C, and which leads to D, and so on. So there is no circular feedback. So we are not focusing on this linear cause and effect feedback, but we are just focusing on the circular feedback. So the performance of a system is not the sum of independent performances of its parts. So we are not taking consideration of the performances of each parts and then joining to find out the performance of the system, but we are taking into consideration the interaction of these parts with each other. So sometimes the interaction will have more value than the performance of the parts. So the total performance of the system can be more than that of the performance of the parts. So it is the product of their interactions. So here the performance of the system is the product of their interactions. So a system contains interconnected parts, which we have seen in the system approach also here, which functions like dynamic and complex webs. So you can see here these parts are functioning like a complex web of interactive loops. So these loops are nothing but these loops are feedback loops. Okay, so these are the interaction between the parts and these are the feedback loops. So next characteristics is that it is an attempt to see the forest as well as the trees. So in system thinking we are taking the whole system. So we are going towards the wholeness, but at the same time we are also seeing the trees also. So we are seeing the forest as well as seeing the trees, means we are taking into consideration the system as well as its parts. Okay, So system thinking explores the interdependencies among the elements of the system. So in system thinking, just now I've said that we are seeing the interdependencies among elements of the system. So we are looking for the patterns rather than memorizing isolated facts. So we are just looking into the patterns for this. So by looking at just one component in isolation, for example in infrastructure, we would not have realistic picture of its importance. So suppose if we are taking the part as an infrastructure in any institution, and if the infrastructure is very good, so we cannot just conclude that the institution is very good, okay, because we cannot get the realistic picture. If there is no interaction of this infrastructure with the teaching learning process, if there is no interaction of this infrastructure with the performance of the students, then this infrastructure is wastage, okay. So we cannot just get the realistic picture if we are not considering their interactions with the institution. So here we are focusing on the feedback loop structure of a system, because that structure determines the system's behavior over time. So this feedback loop structure will determines the system's behavior over time. So why the system thinking is needed? So need of system thinking, because it is needed for solving the problems, because there are a lot of problems which have complex problems. Nature of the problem is complex, and that involves helping see the big picture and not just their parts of it. So if you want to just solve this complex problems, you have to see the big picture and not just their part, okay. So this system thinking can be applied for the recurring problems or those that have been worse by the past attempts to fix them. So you're trying to fix the problems, then also these problems are recurring, then you have to use this system thinking to solve these kind of problems. Then the problems whose solutions are not obvious, okay, you are not knowing what could be the solution of this problem, then you have to use this system thinking, okay. So that is why system thinking is very important for these kind of problems. So just now I've said that this feedback loops are very important in system thinking. So what is feedback loop? So feedback loops controls a system's major dynamic behavior. So this feedback loops generally controls the system's behavior. Then it causes the gross behavior of the system. This feedback loops normally causes the gross behavior of the system. Every parts is involved in one or more feedback loop. You can see here, either there will be one feedback loop or more than one feedback loop. So every part is involved with one or more than one feedback loops. So systems have more feedback loops than its part. If you count the parts, so the loops will be more than its part, okay. So that is why it causes unimaginable complexity. The system is more complex, okay. So these feedback loops are the main reason a system's behavior is emergent. So these feedback loops are not generally the reason for the system's behavior, okay. So this is a feedback loops. So there are two types of feedback loops. One is a reinforcing loop and other is balancing loop. So we will see what is reinforcing loop and what is balancing rule. So all systems behavior can be described through these two basic processes. The first is it contains special terminology that describes systems behavior, such as reinforcing loop or reinforcing process. So here the feedback flows that generates exponential growth or collapse. So either there will be growth in the system through this loop, or there will be collapse in the system through this loop. So that will be called reinforcing loop or process. And the second process is balancing process or balancing loop. Here the feedback flows that controls change and help a system to maintain stability. Here the system will try to balance itself and maintain equilibrium, okay. So these kind of loops generally have a balancing nature or balancing process, where any change when there happens in the system, they try to maintain the system and or maintain stability. So the basic thing is that there are two types of loops: reinforcing process there or balancing loop or balancing process. So let's see the first example, that is reinforcing loops. So the reinforcing loops, they generally compound change in one direction with even more change in that direction. Okay, so either the system will grow or the system will fall. For example, if the person is having more marks, then he will be more motivated and he will develop a good study habit. Okay, and if the person is having good study habit, then also he will get more marks. Okay, so this is the reinforcing loop, means there will be growth in the system. Suppose the person has got less marks, then what happens, he will, it is due to the bad study habits, and if the person is having bad study habits, then it will get less marks, so there will be collapse in the system. The next one is balancing loop. Here the balancing loop seeks equilibrium. Okay, they will try to balance the system to some desirable level of performance they try to maintain. For example, you want to just remove the stress. Okay, so what you will do, you will just do use meditation. After meditation, you are going to just measure your what stress level, and if there is a gap, you want a desirable level of stress, and if there is a gap, okay, now also there is a more stress is there, so there is a gap, then what you'll do, you will again use some more meditation. Again you are going to measure the stress level, and again you are going to see the gap. So how until when you are going to repeat this cyclic process, until you get the acceptable stress level. Till then you are going to just repeat this process and use meditation. So this is a balancing loop where you want to just try to attain the equilibrium. Okay, so this is the example of balancing loop. Second example also we can see here of the balancing loop. Suppose your desired level is that you want 90% marks in your exams. Okay, so what you will do, suppose you have 60% marks, your results are down. So what you are going to do here, the gap is there, so you are going to as a teacher, what you are going to do, you are going to give individual attention to the students because his result is very low. So you are going to give the individual attention to that student, and due to that the result of the person will be up. Suppose this is now 70%, then also there is a gap. You want 90%, but there is a gap, it is a 70%. Again you are going to give more individual attention to the student. Again you are going to just see the performance, and it is 90%. Till 90% is achieved, you are going to repeat this process of attaining academic achievement. Okay, so this is a example of balancing loop. So let's see the importance of the system thinking. We have seen how the system thinking works, so let's see the importance of system thinking. So the system thinking is a way of understanding reality, so this will help you to understand the reality of the system. Because if the infrastructure is very good, generally we assume that this school or this college will be very good, but it is not true, because the reality is different. This infrastructure is not interacting with the classroom situation or students, and that is why the performance is not that kind. So but the system thinking, generally it helps to understand the reality, and this emphasizes the relationship among the systems part rather than the part themselves. So here we are trying to see the relationship between these part or interaction between these parts rather than the parts themselves. So it can helps to design smart enduring solutions to the problem. This system thinking will help you to give smart solutions, enduring solutions to the problem. Then system thinking gives a more accurate picture of reality, so you'll give a very clear picture of reality. So it also encourages to think about problems and solutions with an eye towards the long view. Here you're taking the holistic view of the problem, and you try to solve that problem while keeping your eye towards the long view. So you are going to get the solutions which are long term. Okay, so you're going to get long term solutions of a problem. Then it also helps us to explore interdependencies and looking for patterns. So this will help you to see the patterns in the organizations, and it will see help you to explore how the parts are interdependent through interactions. This will also help you to understand the feedback structures that changes system over time. So you can see the feedback structures changes over time. So this will help you to understand that structures. It will help you to understand the results of our decision if you're taking any decisions regarding the system. So the system thinking will help you the impact of that decision on the system. So these are the importance of the system thinking. So this system thinking involves a shift of attention. So generally we are shifting our thinking, or we are just shifting our attention towards parts. So initially what we have seen in the systems approach, we are more concentrating in the on the parts, we are more concentrating on the things, and that parts are static states, and we are normally seeing the linear cause and effect relationships or interactions, and generally we try to control the problems or solve the problems through control mechanism. Okay, but now in system thinking what we are trying to do here, we are take into consideration whole system we are taking into consideration. Here we are more focusing on the process or the relationship or the interactions. So here we are just keeping in mind the dynamic nature of the system. So here we can see that there is a multiple influences and feedbacks in the system interactions. So we can see here the self organization and emergence in the system thinking. Okay, so we are moving from these aspects. Okay, so thanks for watching. Thank you very much. Please like the video and subscribe the channel. Click the bell icon for notification of new videos. Thank you very much.